Alright guys, welcome to this page of the notes, and again what we're going to do is continue with this idea of solving logarithmic equations, or in this case logarithmic inequalities. And I've got two properties for you for logarithmic inequalities. You should recognize these as the counterparts to the logarithmic, or the exponential inequality, the properties of exponential inequalities. We looked at those in section 2 of chapter 7. These will be the corollary to those, except for now logarithms. And also earlier in this set of notes, we got the property of equality for logarithms, which said this: if you have log base b of x is equal to log base b of y, if and only if x was equal to y, right? So if you have an equal sign, as long as the base of the logarithms is the same, you'll set the arguments equal to each other. Well, same thing here, except now it's going to be for inequalities. I have the log base b of x is greater than the log base b of y, in which case x must be greater than y. Or if I have log base b of x less than log base b of y, because the log and the base are the same, then x must be less than y. So again, all of this corresponds to something we already did with exponential equations, just now we're doing it for logarithms. So it should look pretty familiar. Let's go ahead and see how this looks in an example problem. I will remind you of this. Remember, you cannot take the log of 0 or a negative number, so we might need to watch out for that. I'll show you how it applies. I have log base 4, log base 4. Those are the same, and so I can set my arguments equal to each other, but it'll be the greater than rather than equal. So here's what I've got. I've got x plus 3 is greater than 2x plus 1, right? Okay, so I'm going to solve for x. I'll subtract x to this side, subtract 1 to this side. I'll have 3 minus 1 is greater than 2x minus x, which means 2 is greater than x. Let me flip that around. We have x is less than 2. All right, now, we need to be very, very careful here. Let me draw you a number line. Here's what we're saying. There's 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5. Here's what this inequality is saying. In order for this inequality to be true, I need all values of x strictly less than 2. But I need to be careful, because if I take everything less than 2, I've got zeros and negative numbers down here, and I can't take the log of 0 or a negative number. I'm going to have to worry about restricting my domain. And here's how you're going to do it. Just do a little bit of side work right over here and figure out if you need to restrict your domain. And here's how you're going to do it. You need this argument, x plus 3, to be a positive number. X plus 3 has to be greater than or no. Sorry. Greater than 0. Okay, so that means that x has to be greater than a negative 3. So right away, this guy will be negative. Actually, it'll be 0 or negative if I pick something less than negative 3. So I need all my values of x to be greater than negative 3 to avoid getting 0 or a negative number here. So I've got that guy right there. Okay, negative 3. But that's not the only one. I also have this one. So a little bit more side work. 2x plus 1 also needs to be greater than 0. I don't want 0 or a negative here either. So we solve for x. 2x greater than a negative 1. X needs to be greater than negative 1/2. Well, here's negative 1/2 right there. What this tells me, is I need the values of x to be greater than a negative 1/2. If I pick negative 1/2 or anything less than negative 1/2, this guy is going to be 0 or negative. Well, remember the way this works. I cannot take the log of 0 or a negative. I've got two options. I need the option that satisfies them both, right? This option, -2 is okay. If I plug a -2 in here, -2 plus 3 is 1. I can take the log of 1. But if I plug a -2 in over here, -2 times 2 is a -4. -4 plus 1 is a -3. I can't take the log of -3. However, if I use -1/2 as my restricted domain, what restricts my domain, well then 0 would work, right? So if I plug in a 0, 0 plus 3, well that's a +3, I can take the log of a +3. If I plug in a 0, 0 times 2 is 0, 0 plus 1 is a +1, I can take the log of a +1. And so what this means is I have two options, but I need to pick the option that's the greater number. And so what I get is this guy right here is going to be my actual answer. This one comes from solving the logarithmic inequality. This part of it comes from just doing a little bit of side work to make sure that I'm not taking the log of 0 or a negative number. And your answer, let me get rid of that that highlighter, I apologize. I need everything greater than -1/2, but less than 2, right? I gotta put the two things together. This part right here and this part right here to make sure that I keep the inequality so that the inequality is true, right? That's everything less than 2, but I need everything to be greater than a -1/2 to ensure I don't take the log of 0 or a negative number, right? That's everybody right in here. Let's do another one just to make sure you guys got this down. I got this one for you right here. Again, just quickly looking at it, log base 5, log base 5. So we go ahead and set our arguments to x plus 1 is less than or equal to x plus 4, and let's go ahead and solve for x. I'll subtract x to this side, subtract 1 to that side, 2x minus x less than or equal to 4 minus 1, which means x needs to be less than or equal to a +3. Here's my number line. 3, 2, 1, 0, -1, -2, -3, -4, -5, -6. Here's what this is telling me. I need everything less than 3. So that's going to be everybody going in this direction, right? Everybody going in this direction. But then the risk I run, right, is there are values of x down here that'll give me 0 or a negative number. And I can't take the log of 0 or a negative number. So I need to now work on restricting my domain. Where do I have to stop so that I don't wind up with the log of 0 or a negative number? And like we said, that just requires a little bit of real quick side work. I apologize, that's my highlighter. Get rid of that highlighter. A little bit of quick side work here. All I have to do is just set each of my arguments greater than 0, right? So 2x plus 1 needs to be greater than 0, which means 2x needs to be greater than a -1, which means x needs to be greater than a -1/2. The other one is x plus 4 needs to be greater than 0, which means x needs to be greater than a -4. So here's my two options. Again, I have everything greater than -4 or everything greater than -1/2. Well, we already talked about this, right, in the previous problem. I've got two options for places I need to stop. Which one's the correct one? Well, whichever one satisfies both sides of the inequality. If I were to pick this one, everything greater than -4, like a -3, will satisfy this guy, but it won't satisfy this guy. However, if I go based on the -1/2 and pick something bigger than -1/2, like 0, 0 will satisfy both logarithms. And so I got to go with the one that's the bigger number. And so I wind up stopping right there again, just like the last time. That's interesting. Stop just like the last time at -1/2. And so here's my inequality. Here's my final answer. I need all values of x less than or equal to 3. That's what I get by actually solving the logarithmic inequality. But I have to restrict my domain, because if I pick anything that's less than -1/2, I wind up with a negative number, or I wind up taking the log of 0 or a negative number, and that's not okay. So based on my side work, I need all those values of x to be bigger than negative 1/2, and there is the solution region, right? And you don't have to draw the number line, but it certainly helps you visualize what's going on in these problems. So I would absolutely suggest, it doesn't take you very long, to just quickly draw a number line, your side work, take the results of your side work, throw them on there. You know you need to take the bigger number, right? The one that satisfies both sides of the inequality, and that's going to be your region right there. Guys, that takes care of this set of notes for Chapter 7, Section 4. You should hopefully now at this point be really comfortable with solving logarithmic equations and inequalities. Thanks so much for joining me. I had a great time doing these problems with you. I'll see you next time.